Okay guys, today we're going to talk about balancing equations.
I thought you said chemistry students.
Okay, chemistry students, today we're going to talk about balancing equations. First, you need to know about the 7 diatomic elements of iodine, bromine, chlorine, fluorine, oxygen, nitrogen, and hydrogen. These elements all exist as diatomics. Di means 2, and atomic means atom. So they exist as 2 atoms. These are molecules that when we say iodine, we mean I2. These guys right here are all in group 17. They are the halogens. Oxygen, nitrogen, and hydrogen, hopefully you know right now, are gases. And each of these exist as diatomics, which is 2. Guys, if you have trouble remembering which ones are diatomics, you can just think about the saying, I bring clay for our new house: iodine, bromine, chlorine, oxygen, nitrogen, and hydrogen. All right, law of conservation of mass states that the total mass of the products must equal the total mass of the reactants. In other words, what you start out with, the reactants, must equal what you end up with, which is the products. You cannot have more mass, you cannot end up with more mass, because that would violate the law of conservation of mass. Your reactants and your products have to equal. It also means that the number of atoms in your reactants has to equal the number of atoms in your products, which is what we're going to do today. You balance chemical equations by adjusting the coefficients, which these are the numbers in front of a chemical. Like for instance, 2H2O, the coefficient is the number 2. You leave the subscripts, the little numbers at the bottom, alone when we balance equations. This is the subscript. Coefficients are placed in front, like I just said, and never ever in the middle. So if you have to change the number of oxygens that you need on one of the sides, you cannot put it right here in the middle. So you need another oxygen, you cannot do that. That is wrong. You would have to put it in front. In front, which is the coefficient. Okay, I'd like for you to write these 4 steps down, and we'll go through an example here in a minute. First thing you're going to do, you balance all your metals first. Then you balance your polyatomic ions. Third, you balance any remaining nonmetals left. And last, you balance all your oxygens and hydrogens. Example 1. Okay, let's look at this equation, and how we would say it is zinc plus hydrochloric acid yields or produces zinc chloride and hydrogen gas. We do metals first. So let's look at our reactants here. Every atom that we have in our reactant should equal all the atoms that we have in our products. So we're just going to look at reactants right now. All of our metals. Well, zinc is a metal, so I'm going to put this right here underneath the yield sign. That's the only metal we have. Next, we do our polyatomics. Well, we have no polyatomics here and no polyatomics here. Third, we do our nonmetals, or we balance our nonmetals. So the only nonmetal we have right now is chlorine, besides hydrogen and oxygen. Those go last. So I'm going to put chlorine down here. And last, we do hydrogens and oxygens. So we're going to take care of our hydrogen here. Now let's start balancing. We have 1 zinc right here. There's an implied 1 down here that we're not showing. We never show our 1s. So there's 1. And over here, this is the only compound that we can get zinc from on our product side. So there's 1 right here. Our zincs are good. They're already balanced. We have 1 zinc on the reactant side, 1 zinc on the product side. So now we're going to do our chlorines. This is the compound that we get our chlorine from. We have 1 chlorine right here. The subscript is 1. And over here on this side, this is the compound that we get our chlorine from on the product side. And there are 2, because the subscript here shows that there are 2 chlorines. Now we're not balanced. We have 1 chlorine on the reactant side and 2 on the product side. That violates the law of conservation of mass, because that states that we cannot create mass, and it appears that we have created more chlorines during our reaction, which we cannot do. So we need to have 2 chlorines on the reactant side. So over here, we will not put a 2 down here, because that will change this compound to a different compound. HCl is not the same as HCl2. The only number we can change when we balance equations are the coefficients. So I'm going to put a 2 in front. We now have 2 chlorines. We're going to look at our hydrogens. This is the only compound that we can get hydrogen from on the reactant side, and we have 2 hydrogens. There is an implied 1 subscript here, and we have 2 HCl's. So we have an HCl here and an HCl here. So we have a total of 2 hydrogens. Over here on this side, we have an H2, and we have 1 of them. And in that H2 molecule, it looks like this, and we have 1 of them, and we have 2 hydrogens. So we are good. We are balanced now. Second example, how we read this is copper plus silver nitrate yields or produces copper nitrate plus silver. Metals first. On our reactant side, we have copper as a metal, so I'm going to put that right down here. Our next metal is silver, Ag, and we've taken care of all of our metals. The next thing we're going to do are our polyatomics. We have a polyatomic right here, NO3. As long as it stays as NO3 on the product side, we can keep it together. It'll make our balancing of equations a lot easier if we can keep them together. So that's what we're going to do. We're not going to separate our nitrogens and our oxygens. It stays as an NO3 over here, so we're going to keep it as an NO3. All right, now let's start balancing. Copper, on our reactant side, we have 1. On our product side, we have 1. This 2 right here is representing the NO3. It's saying that there are 2 NO3s. It's not representing the copper. There is a 1, an implied 1 subscript down here. So we have 1 copper. Now let's look at our silvers. This is the only compound that we can get silver from on our reactant side, and there is 1. There's an implied 1 here. So we have 1 silver. On our product side, 1 silver. So far we're good. Our coppers and our silvers are each balanced. Last one, nitrate. We have 1 nitrate right here, 1 NO3 on our reactant side, and on our product side, we have 2. This 2 stands for everything that's in between the parentheses. That means there are 2 NO3s. So our NO3s are not balanced, and as we know from the law of conservation of mass, we cannot create mass, and it appears that we have created an additional nitrogen and 3 additional oxygens, which we know we cannot do. So we need to balance it and make sure that we have 2 NO3s on the reactant side. I cannot put a parentheses and a 2 down here. That will change this compound. I can only change the coefficients, the numbers in the front. So that's what I'm going to do. I'm going to say there are 2 AgNO3s, and that would say that there's 1 there, 1 there. And how many total NO3s do we have? Well, we have 1 right here and 1 right here. So we have 2. Now this changes our NO3s down here to 2, but it also changes our silver, okay? So we need to go back and change that. And now our silvers are not balanced. We have 2 silvers on the reactant side and 1 on the product, which it appears that we have destroyed some silver atoms, and we know we cannot do that. The law of conservation of mass says that we cannot do that. So we need to add another silver on the product side. So I'm going to go over here and add a 2. All of our elements are now balanced. They are equal. We have the same number of copper atoms on the reactant side as we have on the product side, the same number of silver atoms as we have on the reactant side as we do on the product side, and the same number of NO3 ions we have on the reactant side as we do on the product side, so we are balanced. Next example. How we read this equation is aluminum sulfate plus calcium hydroxide yields or produces aluminum hydroxide plus calcium sulfate. Now let's balance. Metals first. So a metal over here is Al, aluminum. And then our next metal is calcium. After we've taken care of all of our metals, then we do our polyatomics. So we've got an SO4 here. As long as it stays as an SO4 and doesn't break up into sulfur and oxygen, we can put it down here as an SO4. So let's look, do our SO4s stay SO4s on the product side? And they do. This is still an SO4. So we're good there. All right, the next polyatomic is our hydroxide ion. As long as it stays as a hydroxide ion on the product side, we're okay. And it does. So we're going to keep it like that. We have no more atoms that we need to account for. We've accounted for all of them down here. So we're going to start balancing. Aluminum first. Over here on our reactant side, this is the only compound that we can get aluminum from. So we have 2 aluminums. This says that we have 2 aluminums in this one compound. That subscript means it goes for the aluminum. Now let's look over here on the product side. We have 1 aluminum. There's an implied subscript here of 1. So we are not balanced. Let's go ahead and balance that before we move on. 2 aluminums on the reactant side, 1 on the product side. That means that we have destroyed mass, which we know the law of conservation of mass says that we cannot do that. So we need to have another aluminum atom over here. A total of 2. I'm going to put a 2 in front because when we balance equations, we cannot change these subscripts down here. So we have 2 aluminum hydroxides. So this number changes to 2. Our aluminums are now balanced. Now let's go to calcium. Okay, on the reactant side, the only place we can get calcium is from calcium hydroxide, and there is 1. And on our product side, we can only get calcium from calcium sulfate, and there is 1. There's an implied 1 there. Our calciums are already balanced, we're good. So let's move on to the SO4. On the reactant side, aluminum sulfate is the only place that we can get our SO4s from, and there are 3 on the reactant side. Now let's look on our product side. Over here, it's not in parentheses, which means there's an implied 1 down here. So we have 1 sulfate on the product side. We are not balanced. We have more on the reactant side than we have on the product side. It appears that we have destroyed 2 sulfurs and 8 oxygens, which we know we cannot do. So we need to have a total of 3 over here on this side. So we're going to put a 3 in the front. That changes our SO4s to 3 because we now have 3 calcium sulfates. We have now also changed the number of calciums that we have, so we need to go back up here, change that to a 3. It appears now that we have created some mass from nothing. And the law of conservation of mass says that we cannot do that. We cannot start out with 1 calcium atom and end up with 3. So we need to come over here on the reactant side and make sure we have 3 calciums. So I'm going to put a 3 in front of the calcium hydroxide because that's the only place we can get calciums. That changes it to 3. Now, lastly, we are balanced. Our aluminums, our calciums, and our sulfates are good. So let's go down to hydroxide. Over here, we have 3 calcium hydroxides. And this looks like, each calcium hydroxide looks like an OH, a C, and an OH. And we have 3 of those. Because that's what it says. It says we have 3 right here. So how many OHs do we have? Well, we have 1, 2, 3, 4, 5, 6 total OHs. Another way you can do this is just take your coefficient and multiply it by your subscript, and that will tell you how many of those total pieces that you have. So 3 times 2 is 6, so we have 6 OHs. Now let's look on the product side. We're going to do the same thing over here. We're going to multiply the coefficient times the subscript because it says we have 3 OHs for every 1 aluminum, but we have 2 aluminum hydroxides. So 2 times 3 is 6. We are now balanced. Last example, metals first. We have an aluminum right here. That is our only metal on our reactant side. So the next thing we're going to do is go to our polyatomics. We have no polyatomics over here, no polyatomics here. So next we're going to our nonmetals, our remaining nonmetals. Well, carbon is a nonmetal, so I'm going to put that down here. And over here we don't have any nonmetals except hydrogen and oxygen. And we do those last. So I'm going to put O and H. We try and do our oxygens and then our hydrogens. Okay, we've accounted for all of our elements. Now let's start balancing. On our reactant side, our aluminum can only come from this compound, and it says we have 4. On our product side, our aluminums can only come from AlOH3, aluminum hydroxide, and it says we have 1, because there's an implied 1 here. So we need to balance, because it looks like we've destroyed some mass. We started with 4 aluminums and ended up with 1, which we know is impossible because of the law of conservation of mass. We need to have a total of 4 aluminums over here. The only way we can do that is put a coefficient of 4 in front. That changes to 4 and we are good. Now let's go for carbon. This is the only compound that we can get carbon from on this side, and it says that we have 3 from the subscript. Over here on this one, CH4 is the only place that we can get carbon on the product side, and it says that we have 1. It appears again that we have destroyed some mass. We start out with 3 carbons, end up with 1, which we know is impossible. So we need to have 3 carbons over here on the product side. The only way we can do that is to put a coefficient of 3 in front, because we cannot change any of these subscript numbers. We now have 3 carbons. Next is oxygen. The only place we can get oxygen from on the reactant side is from H2O, and we have 1 oxygen here. On the product side, the only place that we can get oxygen from is aluminum hydroxide, and that's right here. Okay, here we have 3 oxygens for every aluminum hydroxide that we have. And then we have 4 aluminum hydroxides. So the best way to do this is to multiply your coefficient times all of your subscripts. This oxygen has an implied 1 subscript, and then it has a subscript over here saying that we have 3 of these. So it's 4 times 1 times 3, which is 12. Oxygens are not balanced. It appears that we have created 11 oxygens, which we know we cannot do. We can't start with 1 and end up with 12. So we need to have 12 oxygens on our reactant side. So what I'm going to do here, the only numbers we can change are our coefficients. So I'm going to put a 12 in front. Okay, now we have 12 oxygens. We are now balanced with that. Lastly, we're going to balance our hydrogens. On our reactant side, the only place that we can get our hydrogens from is our water, H2O. So we're going to multiply our coefficient times our subscript. 12 times 2 is 24, so we have 24 hydrogens on our reactant side. Now on our product side, we can get hydrogens from here, and we can get hydrogens from this compound. We can get hydrogens from CH4, and we can get hydrogens from aluminum hydroxide. We have 3 CH4s, and in every 1 CH4, we have 4 hydrogens. So we're going to multiply 3 times 4 to get how many hydrogens we have in CH4. 3 times 4 is 12, and then we have to add that to these hydrogens right here. Now for every 1 aluminum hydroxide, we have 3 hydrogens. So we're going to multiply this coefficient times this subscript, which is an implied 1, times this subscript, which is 3. So 4 times 1 times 3 is 12. 12 plus 12 is 24. So we are very balanced here. We're done, guys.